November 2017, paper 6, variant 1. Question 1. A student reacted dilute hydrochloric acid with zinc oxide to prepare zinc chloride solution. The diagram shows part of the procedure. Complete the box. This is an evaporating dish. Also, evaporating basin is accepted. Evaporating dish, not watch glass, okay? Which of the reactants was in excess? Zinc oxide. The reactant in excess is the reactant that remains at the end. Okay, so since zinc oxide remained at the bottom of the beaker, that means that it reacted وفضل شوية, some of it remained unreacted at the bottom of the beaker, okay? So this means that it was in excess. Name the separation process. Of course, since we saw the funnel, so this is filtration. This is filtration. Suggest why the apparatus would not work. No filter paper present. Filtration will not take place as long as the filter paper is absent. So no filter paper is present. Describe how crystals of zinc chloride could be obtained from the zinc chloride solution. You have zinc chloride solution, and he needs to know how can you obtain crystals of zinc chloride. Crystallization processes are always fixed. Heat till crystallization point, leave the solution to cool down. And if you wanted to obtain the crystals alone in a dry form, you could add, filter, wash, and dry the crystals between two filter papers. But for this question, the marks were on heat till crystallization point and leave the solution to cool down. Okay. So this is question 1. Question 2, a student investigated the rate of reaction between hydrochloric acid and sodium thiosulfate. So this experiment, he's adding sodium thiosulfate and he's changing its concentration continuously by changing the volume of water added. وبيعمل reaction between thiosulfate and hydrochloric acid. This reaction gives sulfur, which is yellow in color. And so he's measuring the time needed for the sulfur to build up here and make the crust disappear, or make the sheet of the paper with the words printed on it disappear from the eye of the inspector. Okay, the faster the rate of the reaction, the faster the sheet of paper will disappear because the sulfur will build up rapidly in the solution. Okay, and he used a measuring cylinder to add the volumes here, and we agreed that using a measuring cylinder is an inaccurate apparatus, so it's better to use a burette or a pipette. Okay, he repeated the experiments at different temperatures. So he didn't change the volume. He didn't change the volume of thiosulfate. He changed the temperature in each experiment, and he's seeing the effect of temperature on the rate of the reaction. Okay, these are the readings. The average temperature, you calculate the average by adding these two temperatures and dividing over 2. Add these two temperatures and divide over 2 to obtain the average, okay? It's like calculating the average in math. And here he wants the time in seconds, not in minutes. So you must multiply the minutes by 60. So here, مثلا 2 minutes, you will multiply it by 60 and then add the 30 seconds. These are the readings, okay? Then he will ask you to draw a graph. The graph is the one in blue. The graph is the one in blue. The plotting must be accurate, okay? Then he asked, from your graph, did you use the time taken for the printed words to disappear from view when experiment 2 was repeated at an initial temperature of 73 and the final temperature of the mixture was 71. Initial temperature 73, final 71, but we have on the x-axis average temperature. So you must add the 71 to the 73 over 2. You have an average temperature of 72. So he's asking, what's the time needed, okay? What's the time needed for the sheet to disappear at 72 degrees Celsius? You must show your working. The black lines دول are worth a mark, and the answer, which is around 53 plus or minus 1 يعني, is for 1 mark, and degrees Celsius is for 1 mark. So the unit, the showing on the graph, and the number. كل حاجة بنمرة. Sketch on the grid the graph you would expect if all of the experiments were repeated using a more dilute solution of thiosulfate. More dilute solution means a lower rate of reaction, means it will take more time. Okay, so the graph must be less steep, the one in green. Okay, the one in green. Okay. experiment was the rate of the reaction fastest? It's experiment 5, because double I explain why, in terms of particles, why the rate of reaction was greatest, because it had the highest temperature, or you can say at higher temperature, particles have more energy, okay, and move faster. So the frequency of successful collisions increase. Please always say the frequency of successful collisions. If this question was a paper 4 question, you could also have said that the amount, the proportion of particles with energy at or above activation energy has increased. But for paper 6, it's enough to say particles have more energy and move faster, so the frequency of successful collisions increase. F, I, suggest and explain the effect of using a burette to measure the volumes. It's more accurate than a measuring cylinder. Okay, more accurate takes a mark than a measuring cylinder takes the second mark. Okay, he wants you to compare between the measuring cylinder and the burette. Type. This question is very important. A 100 centimeter cube conical flask instead of 250 centimeter cube conical flask. Take care. He was doing the experiment خلاص, in order to see the words on the sheet through the conical flask. Okay, assume that this is the 250 centimeter conical flask. Here, the depth of the solution is not that high. The depth of the solution is not that high. Surface area is large, okay, but the depth is not that high. So the sulfur will take longer time in order to build up through all the solution and make the word disappear. Compare بقى if we used a 100 centimeter cube beaker. 100 centimeter cube conical flask, sorry, is smaller in volume. Okay, so it will be like this. What's the difference بقى? The difference here, the difference here is when you look from here, the depth of the solution is larger, and the sulfur will build up faster because the depth of the solution is larger. The sulfur will build up faster and make the time for the crust to disappear decrease. Okay, because the depth of the solution is larger in a 100 centimeter cube beaker, or conical flask. So the crust disappears faster as the depth of the solution is greater. The crust disappears faster as the depth of the solution is greater. Okay, cations and anions, F and G were analyzed. Solid F was iron 3 nitrate. So self F, we had iron 3 as the cation, we had nitrate as the anion. Okay, tests on solid F, complete the expected observations. Solid F was dissolved in distilled water to produce solution F. Solution F was divided into 3 equal portions in 3 test tubes. AI, sodium hydroxide was added to the first portion until a change was seen. طب أنا معايا iron 3 with sodium hydroxide, reddish brown precipitate. Reddish brown worth a mark, precipitate worth a mark. Okay. Added excess of sodium hydroxide in the mixture, it's insoluble in excess. You added excess and it's insoluble in excess. Okay. Type B. An excess of aqueous ammonia was added to the second portion of solution F until a change was seen. Same color, red, brown precipitate. Ammonia with iron 3, red, brown precipitate. Okay. Red, brown precipitate, of course, it's insoluble in excess. Since it's 1 mark, red, brown precipitate is also only neat. Type. Aluminium foil and aqueous sodium hydroxide were added to the third portion of solution F. Take care, aluminium foil is very indicative for the test of nitrate. So we have nitrate and we're doing the test for nitrate. And then he's asking what is the test for the gas? The gas produced from the nitrate test is ammonia. The test for ammonia is damp red litmus paper. If you just read litmus paper, litmus paper, you take the mark, and the result of the test is that it turns blue. Okay, it turns blue. Litmus paper turns from red to blue. Identify the gas, of course, it is ammonia. Okay. Tests on solid G. Tests were carried out and the following observations made. The flame test was carried red. We only have 1 metal in our syllabus with the red color of the flame, which is lithium. Okay. Test 2. Dilute nitric acid was added to solid G. Rapid effervescence, and then the gas produced turned lime water milky, which is carbon dioxide. Carbon dioxide means we had carbonate as an anion. That's why it produced carbon dioxide with an acid. So since lithium is present and carbonate is present, the solid is lithium carbonate. Lithium for a mark, carbonate also for a mark. Finally, an experimental design. He's saying iron, tin, and zinc all react with hydrochloric acid to produce hydrogen. Take care from what he gives you in the experiment, in the rubric, okay? It produces hydrogen, so you must keep this in mind and use it. Plan an experiment to determine the order of reactivity of iron, tin, and zinc. Don't tell me I know that zinc is more reactive than iron is more reactive than tin. He wants you to prove it. You're provided with a few samples of the metals and common laboratory apparatus. Okay, I think I have zinc, I have iron, I have tin, and they all react with hydrochloric acid to produce hydrogen. Of course, the more reactive will produce hydrogen in a faster rate, okay? So we start by adding 25 centimeter cube or whatever, you must say just a known volume of HCl to a conical flask connected to a gas syringe. You must mention the gas syringe because that's the way you will collect the volume of the gas. And then add 5 grams of iron. Okay, start always with one of the metals and then say repeat, but don't talk about the 3 metals at the same time. It's very confusing. Add 5 grams of the iron to the same conical flask. Measure the volume of gas produced by the gas syringe, and you will measure the volume of the gas produced using the gas syringe. Okay, make this using the gas syringe in the first 2 minutes. Always specify a time interval and don't make it 30 minutes لأنه كله هيكون finished the reaction. Okay, so you will measure the volume of the gas produced by the gas syringe in the first 2 minutes. Repeat the experiment with the other 2 metals, tin and zinc. Conclusion في الآخر, the metal that releases the largest volume of gas is the most reactive. The metal that releases the largest volume of gas is the most reactive. Okay, these are 5 points for 5 marks, and mentioning the gas syringe earns you the 6th mark. Okay. Also, if you want a drawing for the experiment to imagine it, this is the conical flask with the gas syringe coming out of it. Excuse my bad drawing. Okay. Here is the 25 centimeter cube of hydrochloric acid, and here the 5 grams or whatever of the metal. The gas goes out, collected in the gas syringe, and you're measuring it for the first 2 minutes. This was November 2017 by Mr. Marco Medhat. Thank you.